Hello everyone. Now we will introduce our backdoor defense via enhanced splitting and trap isolation. Backdoor attacks pose a significant threat to deep neural networks, as attackers can inject a backdoor by tampering with only a few samples. Backdoor attacks can be designed in many different ways. Existing defenses often assume that poison samples are out of distribution data relative to clean samples of the target label. This incorrect assumption leads to the failure of loss-guided split methods that use a clean model to identify trustworthy samples by labeling low-loss samples as reliable. Existing defenses frequently degrade the clean accuracy of the model, even when the dataset has not been poisoned. We leverage the attacker's tampering and train a poisoned model, which successfully splits out a reliable clean pool. In our enhanced splitting stage of ESTI, we introduce the poison model in conjunction with a clean model to initialize a reliable clean pool and poison pool. At the initial iterations, the clean model performs poorly in data separation, causing the poison model to mistakenly identify some clean samples as suspicious. As the iterations progress, the poisoned model can effectively distinguish between poisoned and clean samples. In the trap isolation stage of ESTI, we employ a trap mechanism to flip the labels of samples in the poison pool to a trap label and fine-tune the clean model on the combined dataset of the clean pool and the flipped poison pool to train a trap model. Here are the results of 8 backdoor defenses and our ST against 8 backdoor attacks across 3 datasets. ESTI has achieved superior results in defending various attacks across different datasets, as shown in this table. These results demonstrate ESTI's generalization across different datasets and attacks. We evaluate ESTI under different model architectures. As shown in the first table, ESTI can effectively defend against different backdoor attacks across various model architectures. Since we assume that the defender has no knowledge of any information about the attacker, the defender is also unaware of whether the attacker has maliciously poisoned the dataset. Therefore, it is crucial to evaluate whether the defender can maintain the benign performance of the model when the dataset is not poisoned by the attacker. This experiment demonstrates that our method not only provides effective defense against backdoor attacks, but also does not reduce the model's ACC when training on a clean dataset. Our method does not make any assumptions about the attack settings. We evaluate the performance of ESTI across different target labels to assess its robustness. Since the GTSRB dataset has an imbalanced number of samples across classes, defending against attacks targeting different labels on this dataset is more challenging. ESTI can effectively defend against various attacks across different target labels. To investigate the impact of poisoning ratios on the effectiveness of ESTI, we conducted experiments using different poisoning ratios. For dirty label attacks, we used poisoning ratios of 5%, 10%, 15%, and 20%, while for clean label attacks, we used 2%, 4%, 6%, and 8%. The results with different poisoning ratios are shown in the second table. Our approach demonstrates notably stable defense performance across a range of poisoning ratios. We evaluated the effectiveness of our enhanced splitting stage. Specifically, we trained a clean model on the clean pool obtained through enhanced splitting and evaluated its ACC and ASR, denoted as E's. We compared its results with those of the model trained on all clean data of the training set, denoted as ACD. As shown in this table, the ASR of ES is close to that of ACD. However, the AC of ES is slightly lower than that of ACD. With the introduction of the trap mechanism, ESTI achieves an ASR even lower than that of a CD. This is because ESTI isolates poisoned samples in the trap class, flipping poisoned samples predictions to the trap class during inference. ESTI reducing SR to levels lower than that of SAD represents a meaningful success. Thank you.